Alright, here's what we're working on today. They had a Honeywell controller and a sequencer controlling the VFD and 60 tons of cooling, 6 different compressors of various sizes. They also have a boiler and a hot water valve, and that boiler is dedicated just to that unit. So it's a very small loop, and the water heats up really quick, which is nice. The old thermostat was analog, and it was putting out 1 volt all the time, and that kept the fan running all the time. The start-stop relay for the VFD was wired directly into power, so the VFD was always enabled, and if it had any sort of a signal like 1 volt or just a few volts from that old thermostat, the fan would run continuously, and that's what it was doing. So what we did was we took out the Honeywell controller, and we staged the compressors, and we also had to use these power supplies to stage the fan speed. So what we have here, Y1 from our new thermostat comes in and triggers this relay. This relay will bring on the first 2 compressors. So this one line goes out to do that 1 condenser. So you get the first condenser, which is approximately 20 tons. Should be like 20, 40, 60. So approximately 20 tons off of the Y1 call for first stage. The Y1 call also comes up here and triggers the time delay relay, which controls second stage. So then you have a 20-minute delay, and the time delay relay brings on the second stage, so you have another 20 tons come in 20 minutes later. This relay also triggers a relay which allows 6.6 volts to go through to the VFD signal. So then the VFD ramps up to 66%. I should have mentioned, as soon as you get a fan call, the VFD start-stop is enabled. So our fan command comes in and triggers this relay, which is our start-stop, and we have 3.3 volts at all times going to the VFD. So anytime the start-stop is enabled, the VFD will ramp to 33%. So 3.3 volts, 6.6 volts, and 9 volts. 9 volts for the third stage, and also for our heat call. So let's see. Second stage is Y1 after a time delay, and also brings in 6.6 volts. Y2, the Y2 call, brings on our second time delay relay that is set for 40-minute delay, and after the 40-minute delay you will get the third condenser, which is another approximately 20 tons. So now you're at the full 60 tons after a 40-minute delay. And it comes down here and allows 9 volts to be passed through to the VFD. So first stage, Y1 first stage, you get 20 tons. 20 minutes later, you get another 20 tons, and the fan speed increases. And 20 minutes later, you get another 20 tons, and the fan's speed increases again. For the heat call comes in W1. W1 comes up here and triggers a bypass relay. And now these 2 relays are basically redundant. So this relay gives you 9 volts from your power supply to your VFD, so that you can run your fan at basically full speed during heat mode. Also, the W1 call goes out on this 2 conductor, and it goes with all the other wires through the wall, and it comes over here to the pump start stop. So your W1 triggers this relay. I also noticed that the induction fan for the boiler was running continuously, and then I found this switch, and it's the boiler start stop, sort of. It gives power to the boiler, but the boiler doesn't run unless it has flow. So anyways, I put a relay on that to kill that constant run fan. So my W1 call gives me pump, and it also gives me boiler power, which gives me induction fan, and the boiler fires up because it has flow from the pump. Previously, this boiler was controlled only by the outdoor air temperature. So when the outdoor air temperature was below, I think they had it set for 60 degrees, that would bring on the circulation pump contactor. The circulation of the water would trigger the flow switch, and the boiler would fire up. And they were using that for heating purposes, and also I guess for a little bit of freeze protection. And so the way that we kept freeze protection in the loop is this relay here for the circulation pump is in parallel with the outdoor temperature control. So the outdoor temperature control can still bring on the pump, but because of the relay we put on this flow switch, it will not bring on the boiler. So, and then we set it also for 35 degrees. So at 35 degrees or below, you'll run the pump to circulate the water, but you will not be running the boiler. I forgot to mention that. So there are 4 relays that the W1 call does. The W1 call enables the flow switch. So this relay is in series with the flow switch. It enables the boiler, and it brings on the pump because that relay is in parallel with our freeze protection. And the 4th relay is the relay that ramps up the fan speed. So we're testing now. I got 108 degree supply air temp when I enabled the boiler and ramped the fan all the way up. They also have this was one problem that we were trying to overcome. They have a water valve in place, but it's 2 to 10, and so we were going to use another one of these power supplies and bring in a 10-volt signal with a relay to position that valve, but it didn't work. It didn't work. It has something to do with the common, and when you try to jump the common from the valve to the common of the transformer, it does not like that, and it's because this is a bridge rectifier, and you can't jump one side to the other. It just didn't work. Luckily, in this situation, there's only one unit being served by this boiler, and you're never going to have the boiler running when you need cooling. So this can be a wild coil, and so that's what I've set it up as. I've opened that valve, and the signal doesn't do anything, so it's wide open. It's also nice that this is a small loop because the boiler kicks on, and just a few minutes later you have very hot water. So it doesn't matter that we don't run the boiler, they're never going to notice. It's great. Now we're just testing all of the stages of cooling. It's been a little while. I've been calling for the 3rd stage, and it still has not come on. So there's something strange going on with a mechanical failure with this last condenser. I've got 2 condensers actually working, but this 3rd one, even after quite a long delay, still has not come on. So I'm hoping that we have enough tonnage to cool down that large auditorium.